I didn't get enough sleep. So we'll see if all this happens. But in this programming language, of course, there are some things in it that are just like almost every programming language. And one of those things is that you have variables that go by names, right? So this thing handled is a variable, and arg and index are variables, and args, right? And just like all of the C style languages and many others, variables are organized into scopes. So wherever you declare them, you can access them in that scope, and scopes tend to be delimited by braces, right? So this is a scope from this brace to this brace, and this is a scope from here to here, and this is a different scope. And if you introduce a new variable inside a scope, it's valid in that scope, right? And nobody outside the scope can refer to it. And then somebody trying to use that variable inside that scope will find that definition. Or if they don't find it, you sort of traverse up the scopes in what's called lexical order, which means the way it's written in the program text. And this is, there are different ways of organizing programs. Some Lisp-like languages, for example, have a thing called dynamic scope, which works differently. I think all that is kind of garbage in terms of program organization. I think, historically and empirically, lexical scope plus static typing has proven to be the most robust paradigm for organizing the way your variables work. Okay. So is there any questions about that before we go on and talk about what we're actually going to try to do? What is up with this case x64 line? We'll demo this in a later demo, in an official demo. No questions about variables and lexical scope? Okay. So, the egregious amount of white space. Yeah, okay. It's true. It's true. There's a lot of white space there. How do I line it up with this? Is that, I need a vertical alignment here. Anyway, so scopes, of course, have an internal representation in the compiler. Yeah, I know Lisps can have various scoping implementations. I'm just saying that many of them did dynamic scope, and you'll find advocates for dynamic scope, and those advocates tend to like Lisp-like languages. Okay. Of course, we have an internal representation by which we implement these scopes, right? And that is this thing called a block. And we have some stuff that's like bookkeeping that just helps the compiler do things. Like if this block is internal to a struct or a lambda, if we record that fact, it'll help us do some things. But there's the two important things that are sort of user-facing. One is the parent, right? So this help makes the linked list of lexical scoping that we walk up in order to find identifiers. So if a block, if a new block is introduced, then we take the current block and make it be that block's parent. And then when you look at an identifier, you walk up this series of links from block to block, okay? And the other one is this members array, which is the declarations that live in that scope, right? This is how all the variables are defined. So you walk up to this link to a new block, you search this members array to see if the variable you're looking for is declared. And if it's not, maybe you walk further up. Now, anyone who's experienced in compilers knows maybe an issue here. This is a linear array, and no, we're not doing any fancy searching on this, right? So in cases even, like just say I'm not even using variables yet. Say I want to add a new identifier to this scope. Well, I want to report an error if that identifier is already declared. So what do? Well, I search this members array to see if there's another identifier with the same name. If there isn't, then I add the new one, right? Okay, first of all, that is an order n squared operation, where n is the number of declarations that you're adding to a scope. That is not fast for those of you who didn't go to computer science school. Well, it's not, quote, fast, unquote, right? But the fact is, we're still faster than most compilers right now, right? So if I go, especially if I use our x64 backend, we compile in about 1 second. Actually, 1.1 that time because things were not in cache. 1 to 1.1 seconds, okay, for a 75,000 line program. However, that's pretty slow. We used to compile a lot faster than that. And the reason we're slower is because we started, for example, doing a more complete implementation of some of the libraries. So, for example, Ignacio did some OpenGL stuff. And, well, right now, I think we're using this thing called Glad Core, where he did this thing where he generated all the OpenGL bindings from the specification. And, well, you can see that there's a lot of declarations, right? All in one scope. And that's the terse version. So the terse version of this file is 2,800 lines, most of which is separate declarations, 1 per line. But that's not that's the fast one. So there's glad all, which is like every single thing that has ever been declared in OpenGL, most of which is extensions that are deprecated and you don't want to use. But we have that for the sake of completeness. That's 13,000 lines, right? So it's more than 4 times as big. Blah, 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 all in one scope. So when you start doing that with this kind of n squared operation, it starts actually being slow. Now, it's a lot faster than most people think, because when you have a contiguous memory array like this, your cache locality is very good and your performance tends to be good. Which is why we can compile a 75,000 line program in 1 second. And by the way, half of that 1 second is the linker that we're not in control of, right? So we're really compiling in half a second. But we want to be able to compile much faster than half a second. And a while back, if I was being a good citizen today, I would profile this and show you the profiling times. And show you that this is slow. But we actually did that on an earlier stream, and that might be archived on YouTube. And I don't have my profiler set up on this machine. But you just know some things, like, yes, premature optimization is the root of all evil, and you should always profile before you optimize. But this is just something that we have to do. Like, this is an untenable thing to do when you can have programs with 20,000 declarations in a scope, right? And so, of course, this is n squared with the number of items that you add. And then, for any individual identifier that you look up, that's order n. And that's not good. But this is a fast way to do things. This is faster than a fancier data structure at some small size. So what I'm thinking is, I want to make a system where we still do this for low numbers of declarations. But once the number of declarations exceeds a certain amount, we roll over to using a hash table or something like that. It doesn't really matter what it is. I'll probably do a hash table. Actually, I'll do something even dumber than a hash table at first, and we'll talk about what that is. So we'll do the same thing for short, and we'll switch over to something more complex for long. And in principle, hopefully our compile time will go down when we succeed at this. Now, again, a lot of the program probably touches this. So we're going to go through an initial phase of identifying and quarantining the parts of the program that need to change. I don't think it'll be nearly as much as in yesterday's Lambda refactor, but I could end up surprised. So, any questions about all of that? while I'm waiting for questions, because we're going to work on this thing, I'm going to move it up to the top of the struct here because we're going to introduce some number of members. And let me just, I don't think there's any dependency on where that is in the struct, but let's just compile again to make sure. Because you never know. Sometimes in a big program, you can be surprised. Do I like generated code? No, I don't. Would I say this would be a good point for me to make getting members be via a function? Maybe, probably, yes. Often it is by a function, right? It's just maybe not a... So looking up an identifier in a scope is a function, right? So we just change the implementation of that function for those cases. But there's other things you do with identifiers in a scope besides just the naive lookup like that. And, you know, those things will have to be modified. If declarations are just a list, how do you detect used before declared sorts of errors? The declarations themselves have the information on where in a file they are. And so when an identifier looks up its declaration, it just says, is this declaration after me or before me? Okay. Now, before we do any of this, I want to disable a certain thing. There's a thing that I did a long time ago called global scope optimization, which was a way of... So way back when I did the initial version of this... Oh, so I would like to point something out philosophically, which is, yes, this is slow, but it was fine for several years of my work on this compiler, right? I'm only just now getting around to making it faster. And what that means is it was good enough. In fact, it's still good enough. Like compiling in 1 second is pretty good, you know, for the x64 version. LLVM is slower, 2 seconds. Compiling in 1 second is pretty good, but, you know, we have standards here, and we want to compile in much less than 1 second. So, it's just to say, though, that the fact that we're going and speeding this up now is not at all an indicator that we did anything wrong. In fact, it's the opposite. It's that this very simple thing got us really far and helped us figure out a lot of things about the language. And so it's a very good example of the kind of programming that I like to do, where you just do something simple to lift yourself up and propel your progress forward. And then later, when you know really well what you want to do, you can make it more complicated and faster. Are the OpenGL bindings included in that 1.1 second compile time? Yes, the shorter version, not including all the crazy extensions, just the ones, the basic ones. Won't switching between lookups implementation add too much complexity over just using one that is good enough? Maybe. Like, I mean, maybe I should just have hash tables and not this array. Just having this array is not a tenable solution, right? Large programs will barf on this. So we have to do something more complicated than this, as much as I wish that weren't so. But we can still try to do something as simple as we can. In the long term, honestly speaking, whatever we do will probably get complicated because identifier lookup is a large percentage of what a compiler spends its time doing. So anytime it's a large percentage of your time, you want to spend a lot of effort in making it fast. And that usually makes things complicated. So it'll probably get complicated. Our goal for today is to not make it too complicated. We just want to make it complicated enough to get the majority of the speed benefit potential. When do I plan to get rid of the linker? I don't know. That's one of the things on my mental list of stuff I want to do someday. But also that Lambda refactor that we did yesterday was on my list of stuff I want to do someday, and that one's checked off. And this scope refactor was on my list of things I want to do someday, and now it's getting checked off today if we complete it today. So yeah, these things happen eventually. Does the x86-64 backend reuse stack of variables that go out of scope? C compilers usually don't do that, and I'm not sure why. No, we don't do that either. It's just being picky about stack size like that is not really very useful, I guess. I haven't seen a point to doing it. Is this stream going to include the actual implementation of a hash table? Well, we already have a hash table that we're probably going to copy and paste the code of. So you'll at least get to see that. I probably won't type it in from scratch. Have I been researching any good hash table implementations for your case? No. What we're going to do today is just put in a basic hash table. It's probably not going to be the absolute fastest solution. It doesn't matter because the complexity in the software is not really in whatever is that data structure, right? The complexity comes from changing the whole system to use this more flexible thing where we switch over from one representation to the other, and to get it to no longer rely on the representation that it historically relied on. That's where most of the work goes. Then, once we've done that, if we don't totally like this hash table, it's much easier to swap it out for another one or for a different data structure like a binary tree or who the hell knows, right? Skip list, anything. So that's the easy part. The harder part is to just get the compiler working successfully with a new data structure, right? We should be able to make identifier lookup substantially faster with just a totally arbitrary hash table. Like that should just be a thing that we can do. What happened to the eye tracker? I'm just not looking at the screen a lot of the time right now. I'm looking at my other monitor where you guys are talking on chat. Yeah, so, again, to be clear, I'm not getting serious about profiling today. I'm not getting serious about judging what the data structure should be. I'm just making it possible to do something else. And so that actually, okay, here's going to be the funny thing, right? When I do this, and this isn't the first thing I'm going to do, I'm going to go do the global scope optimization. But what I just said was it doesn't totally matter what the other data structure is. And so what I'm going to do is the following. I'm going to say, I'm going to rename this something like, linear members array or something, and make very clear what it is performance-wise. And then I'm going to make another data structure called other linear members array, and it's just also going to be linear. And we're going to fill this one up. And then when this gets too full, we're going to empty it and put all the members here and set another flag. And that's it. That's our initial acceleration data structure, AKA no acceleration, AKA actually it'll be slower because you pay some performance cost from moving all the guys from this one into this one. So initially it's going to be slow and stupid, but it's going to structurally do the job, right? And so once we get the whole compiler working with this, then we get to swap this out for whatever data structure we want. And so, somebody asked yesterday of how do you solve big problems? And I said, well, you compartmentalize the problems, you break them down into substeps. And here is a way of breaking them down into substeps, right? Step one, this is not the smallest substeps, but like, oh my God, how do I change the representation through the whole compiler of the scope storage? Well, break it into separate problems. Break it into the problem of making sure that you can switch over between things, right? and then the separate problem of implementing the thing that's supposed to be faster. Those are two separate things, and it's very easy to split them cleanly and to implement only one. So now I've made my job simpler. I can implement only one. And that'll be a milestone. I can even check the compiler in. In fact, I will when I've implemented only that one, and then we'll actually go and do the hash table, right? So does that make sense to people? But I'm not going to do this yet. So let's talk about global scope optimization. I'm going to leave these commented out for a second. Wow, I'm getting tired again. I might do breakfast. After this explanation, I might do breakfast and take a nap, and then we'll come back. Because I don't want to start this when I'm like super tired. Okay. So global scope optimization. Back when I, maybe more than a year ago, programs started getting big that we would implement. And I was like, yeah, this linear array thing is slow for big scopes, but really the biggest scope is the global scope. Because when we import libraries right now, because the library system isn't that sophisticated, all the identifiers get dumped into the global scope. It's just like what happens when you include things in C, right? And so the global scope got really big, and I was like, well, I already have this hash table for atom lookup, where atom lookup is just, the word atom is an abusive terminology, but this is, again, that thing that comes from Lisp-like languages. And it's like the compiler internally has one storage place for any particular identifier, so that during, when you make an identifier, it's essentially an entry into this hash table. And then if you ever want to compare two identifiers to know if they're the same, you don't have to do a string compare, right? You just compare the pointers into this hash table. And so it's an integer equality comparison, right? So that's a useful technique. And so I was like, well, if we have this hash table, we can use it to store where people are in global scope. So that's an optimization that I did. However, a while after that, maybe 6 months after that, I did a thing where files ended up having file scope. And if you don't export things explicitly, they live in file scope. And so global scope maybe ended up not being as big as it was. But also, now that we're going to do this new hash table thing, the global scope optimization is going to make things more complicated, right? We want to remove this old optimization to get back to a simple baseline where absolutely everything uses that array, including the global scope. And then we want to recomplicate after we've done that. So my first step is going to be removing this if-def completely. And that'll probably make the program slower somewhat, because a lot of things in libraries are exported. It's just a lot of identifier lookups don't go all the way out to the global scope, but the ones that do are going to be a lot slower. We have a question. Currently, what you're doing is making the code front end of the problem work and only then putting in the proper data structure back end of the problem. Yes, that is correct. Now, thinking about it in terms of front end, back end decomposition makes sense, but you also want to be able to decompose problems into more parts than that. So at some point, you stop having front end, back end style names for all the parts, and you're just like, well, I see the parts in my head. That's what Per Vognsen calls interning. Yeah, probably. Yeah. A lot of people call it interning. I probably should call it intern or something instead of atom, because atom doesn't mean anything. Like, the reason it means atom in Lisp is because it's not a list, and so it's not decomposable, but it doesn't, in a language like this, it's not list-based. It doesn't make sense. Would it be possible to inject the scope depth during parsing so that you can do a direct lookup for a variable instead of traversing a linked list of scopes? Not really, because you don't at parse time know what all the identifiers are, right? Somebody could say, I'm importing a library here. That library is somewhere else. We may not have loaded it yet when we're parsing this. In fact, we probably haven't loaded it yet. The meta program may add code that declares new identifiers. We may be using a data structure that has a body text directive that requires a procedure to run to generate the members of that data structure, right? So at parse time, you can't know in this language what all the identifiers are. The language is we'll say too expressive for that. If it were much simpler like Fortran or something, you probably could do that. Will we see a game in with Casey night sometime soon? Well, I live back in San Francisco now, and Casey lives in Seattle, so it's not likely anytime soon. Okay. Let's start. Now, to add extra complication to global scope optimization, last time I looked at this, I have a vague memory that I was doing something dicey in here. Like, let's just look at it, not in Visual Studio, because Visual Studio is terrible. But so when we add something to scope, if we have global scope, like global scope optimization has been set to true for a long time. So it's quite possible that we're doing something in here that we shouldn't. Okay. Let's see. And I don't know if I'm going to need global namespace mutex anymore, but I'm going to keep it just in case. Okay, so what do? We get the atom from the identifier. We look if it has a declaration in global scope. If it's a placeholder, we do this. Okay, this placeholder stuff is fishy to me because if we don't, like, do we only handle placeholders in global scope right now? If so, then that's wrong. Maybe it's not wrong. I don't know. We do this overload registration. Maybe this stuff is happening in somewhere else for non-global scope. I don't know. It would not be good organization of the program. It's not, something is scary here because we're doing all this work that should be true regardless of scope. So let's just see who talks about placeholders. So we have another thing called checked add to scope that calls this, and maybe that does placeholders. So that's what we were just looking at. Placeholders can only be given at top level. That's when we add a placeholder. This is when we're looking up an identifier and we find a placeholder. We say, well, we can't look up that identifier yet. This is when we're explaining what's wrong with the program. We can say, oh, you defined a placeholder, but you never gave us a value. This is if we're making a placeholder. This is when we're inferring a declaration that hasn't been filled in. Find declaration helper. Okay. This says if it's a placeholder, yeah. So just turning off global scope optimization may be a challenge. what did I say here? If it's a placeholder and not in the global scope, ignore it. We do this because currently code added from a run isn't going to go into this file scope. So the placeholder sitting in that file scope will never be replaced. And it'll just act as a barrier to successfully resolving the identifier even after it's added. Okay. See, this is good comments. These bullcrap comments that people write about like n is an integer on the declaration that says n int, right? Those are not helpful. But like this kind of thing, like let's explain why this is here, is a good comment. And I'm glad I did it. It's almost a 1-year anniversary comment, 27 May 2017. Today is 26 May 2018. So a 364.25 day ago comment. Thank you. Thank you, past me, for writing this. Have I tried R++ extension for Visual Studio? No idea what that is. You wouldn't happen to know anything about quantum computing. I took a quantum computing class, and so I understand that much about it, like some theoretical things about it. I don't know anything about implementation of it in the real world. There's a whole stream about placeholders on YouTube. It's a way of getting better error messages when you have a system that adds variables later during compilation that parts of your code want to use. And I talk about what that's all about. Okay. So it looks like we clearly do not have substitute placeholders if global scope optimization is turned off. So that's going to be our initial job, is just to make that work with regular scopes. Okay, let's just dive in and do it. Now that we know that's what's happening, okay, I'm gonna go old.text, and I'm just gonna cut this code. Register overload must already happen. So we're gonna, when we come to do this placeholder stuff, we're gonna look for, because overloads work in every scope. And we're not going to need this part because that's redundant with errors we already have. Okay, so we're going to get rid of global scope optimization. We're going to say if we're adding something to the global scope, you know, if it didn't have an identifier, we would put it, yeah, whatever. Okay. If it's in the global scope, we're going to lock the mutex. Whoops. And we're just going to use a scoped lock. Right. Otherwise, we're going to do that. All of this is gone. Right? Okay. Let's look for global scope opt. That's gone. Get from global scope. Okay. Get from global scope. Well, when we rename the members array, we will catch this. So I'm not going to worry about that. Okay. But you notice get from global scope there had sort of its own implementation of identifier lookup separate from the main one, and that seems not good. Okay, so we're going to do this. That's gone. And that's gone. Now we also want to get rid of declaration in global scope. Oh boy. Okay, we're using that in some places. This is to figure out okay. I think I can just delete this. Let's cut this. This is just for generating debug names for procedures for like the backends, which tend to want string names for things that conform to certain things. So that was just like, look, if we have a global declaration, we'll do something. And I think it was just like, let's make that be a canonical name and not mangle it as much. But we have other ways to do that, I think. Now, of course, something might break. Like one of the backends might rely on this making main be called main underscore or something. So who the hell knows? All right. But we're getting rid of this. Getting rid of this. Okay, let's edit that in Emacs because that's complicated. And find global struct binding. Wow, that sure assumes global scope optimization. All right, so yeah, we have a job ahead of us just to do this. All right. So who is not happy? Typer 7471. Like I said, optimizations make things more complicated. That is just how it is. Okay, so find global struct binding. We're looking for is it called did I call it? What is it called? Global namespace mutex. All right. So we're just going to, okay, do we use this? I think we do. Yeah. For error reporting in exactly one case. Great. Okay. But we're explicitly not looking it up by name. So here's what we do. We're going to need to implement this separately later with the hash table because it's not an identifier. Look, like I said, you want to do things with the set of identifiers in a scope besides just naively look them up by name, right? And one of those things is something like this, where we want to look at all of them and say, is it a struct, right? So is it called global scope? Yes. So for block of members, okay, so if there's no expression, if it's not a type, okay, so this is all fine. So this is what we want. We just want linear member scan. And then when there's a hash table, we'll if def, or we'll check the flag and we'll do a hash table scan or something. Okay, main line 630. Okay. Here I was just doing a hack to find the entry in global scope. I just directly used it. So instead, we want to say is it find declaration? We don't have an identifier. Okay. We'll use find declaration helper. So find declaration helper interp entry point atom do we need an identifier? That's a site. Interp atom site current scope. This is not a very convenient function because it's not ident scope. Detect placeholders. Can continue. Okay, so we need a site here. Why do we need a site? See, this thing also, it doesn't just look up something in a scope, it like does identifier stuff. Okay, we're going to make site optional. Come on, Emacs. Bruh. Fine, we'll just delete all those comments rather than indent them. Okay. Let's make sure nobody else dereferences site. Nope. Blah, blah, blah. Blah, 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 blah. We might want to simplify this whole thing later to not do all this in one function. But for now, I'm just going to try to do the minimal changes and get the compiler working without the global scope optimization. So we don't have a site to pass, so we allow it to be null. Okay. Let me put that at the very top. So all right, fine. So main find declaration helper 4 from atom star to block star. That's ident scope. One, two, three. No, that's current scope. Ident scope. Wait, what? Why did I do entry point atom? No, it's global scope. What am I doing? Why did I type entry point atom twice? That's the wrong. That's when you know I didn't get enough sleep. Oh yeah, and I got to delete my old one. And look, it's an old report error that didn't, it had too many arguments. Same here. I must have been used to printing out the hex name, and now I'm not anymore. All right. All right. Well, it compiles. Is not going to work because we haven't put in the placeholder stuff. But how much do you want to bet we don't even get an error? It just crashes. Let's see. Oh, we got errors. Redeclaration. Redeclaration. Oh, the other one is a placeholder because our placeholder detection is not working. That's great. That's great because we didn't crash. We just didn't have the thing that we don't have. All right. So now let's go to this. Where we must call register overload from somewhere else. And that must be when we detect. Okay, check for redeclaration. Okay, so if the names match, it could be an overload, in which case, whoops, in which case we don't actually add a new declaration. We like have a sub list for any particular overload, and you know, whoever was there first sort of acts as the master header for everybody in that scope under that name, right? This is for procedure overloading. Okay. Okay, well, so we can check for placeholder there. Well, okay. So this, we set this to true if we did something with this guy so that the caller doesn't have to explicitly add them to the scope. Yeah, okay. So this is handled. Okay. So if the old one is a placeholder, actually let's handle this one, because this one's easier. Actually, I don't know which one's easier. Let's just paste this all in there. Pasting it all in there. I don't know why I'm returning false, but I don't know what false means, but it means something. Okay. So if these are not called other now, so instead of other, it's decal olds. Okay, and then, whoops. And then instead of decal, we have, oh God. Decal, we have decal new. Wait. Okay, hold on. We're structuring this a little differently. Hope I'm doing the right thing here. Okay, something like this. Okay. So, if the old declaration is a placeholder, then okay, we want to drop the new one into the array where the old one was. And maybe I need to do something else, but who knows? Okay, so I have to go to an explicit, because C++ is not good about iterating. Okay. So here we say scope members I equals decal new. Right? And then if the new declaration is a placeholder and the old one is not, we just throw away the new one here. Okay. This is first glance plausible. I probably screwed it up badly. Let's do a line count now. I didn't, whoops. 41493. So yesterday at the beginning of the day, before we did all the lambda refactor, we were at 41513. And then we did the lambda refactor and we ended up 13 to 20 lines. Now we're down 20 from yesterday. So we're below 41,500. That's good. Of course, it's going to get bigger again when we add the hash table and all that. But, you know, we're managing. Now let's see how bad we crash. Well, we panicked or something. Okay. Well, this might be a good time for me to get breakfast and then come to maybe take a nap and then come back and use my newly refreshed debugging brain. Let's see. What is wrong with you people? All right, collection was modified. Anytime that happens, I don't trust it. You gotta rebuild. Is the eye tracker super hard? I mean, we don't want it to be super bright because then you won't read the text, right? It should be just enough to give you the information. I don't know. What do people think about the eye tracker color? Someone's complaining about it in chat. Have I played Human Resource Machine? I have not. The one thing you like C++ headers for is to define an API in a compact way. Yeah, we will have different ways to do that. I wouldn't worry about it. Like, metaprogramming can do a better job than that. Okay. So let's just see what our panic action is here. Let's get rid of all our breakpoints. These are yesterday's breakpoints. We don't want them. Oh, look, we're just freaking exiting. Oh, we're exiting because that's an option for a different program that we don't understand. Okay. Well, we went a while. Okay, declarations in closing scope was null. That's not good. This probably happened in the placeholder stuff that I just did, right? Yep, nonentity types is one of our placeholder things. So when you put a declaration, you have to say what scope it's in. All right. It's going. It's going. It's going. We have no global scope optimization, so it's going a little. Oh, I didn't see if that outputted an error or not. Let's be spicy and build the release build. Okay. Wow. That is a good first step. That I'm happy with that. Well, let's see if we can run the tests. Yeah, this is better than I thought that this would go. Okay, this is great. So global scope optimization is gone. We are now at 41494 lines. I'm going to write that down because this is the point from which, when we resume, we will start adding the complications and all the thingies. But first, I'm going to get breakfast. I'm going to nap. I'm going to take my morning shower and whatever. So it'll probably be more than an hour when we resume streaming, but we will resume streaming. And that was a good just a little early morning. Drop in, answer some questions, get a basic thing done. Let me check that in. Check it in. Disable global scope optimization as a prelude to... I wonder where Subversion gets all its tags from. That's weird that it knew that completion. Disable global scope optimization as a prelude to making scopes faster in the scopes monkey trial. The line count at the beginning of yesterday was 41513. I don't remember what it was at the end, but it was higher than that. All right. Thanks everybody for coming by. We'll resume in a little while. Do I have low latency